Okay, so I guess any announcements that I have before we start the lecture? I sent out an email, a very important email. Sent it out. Looks like I sent it out probably February 22nd, a few days ago. But this has the reminders as well as some information about next week's exam. So as I mentioned in class on Monday, we have an exam the following Monday. So, well, the first thing, the assignments, the homework on position and 5-number summary was due last night, and the corresponding quiz is due tonight. Make sure you do the quiz. The correlation coefficient, the homework on that. So what I ended up doing is I split up chapter 4 into just section 1 on the correlation coefficient, and then the other part of chapter 4, we can reserve that for another time. So just this section on 4.1, that's due Friday, February 26th. And as I mentioned, the exam is next Monday. So also in this email I sent out, again, you might want to be aware of this email. It's got a few important tidbits of information about the first exam. We're going to take the exam during class time next Monday. We are not taking the exam here. The exam is not in this classroom. It is in the library. So do not show up to this classroom. I will send out probably another email to emphasize this. This exam will be taken in the math tutoring lab in the library, the second floor, room 208. As soon as you climb up the stairs or you get out the elevator at the Sims Library, it's the I guess the room with all the glass panels. You can look into it. There might be yellow cups on the computer monitors from back when we used to run the math lab over there. But we are not meeting here next Monday. If you show up here and you end up rushing over there, I might be able to give you some extra time to take the test, but it's going to be a little bit difficult with all this COVID stuff going on. There's only limited seats. I have to know who's where at what times. Question?
Is the exam one considered our midterm?
We technically do not have a midterm in this class.
I can't remember if you said that like in the beginning or not.
Yeah, we technically don't have a midterm.
But we have a final.
We do have a final.
Okay.
And the final is going to be weighted the same as the 2 regular exams. I didn't want to do a midterm because, did you take 105 last semester?
No.
Okay, well, yeah, they had it to where the midterm and the final were both 30% of your grade, and I really didn't want to do that. In case someone bombs it, that means you pretty much fail the class. So this way it kind of lessens the blow if somebody does it bad on the first exam. It's only 20%, which is the best I could do under COVID circumstances. So no midterm in this class, but we do have 2 exams. And
so this will be the first exam, and our second exam will be considered the final, or 2 exams and a final?
There's 2 exams and a final.
Okay.
Yeah, 2 exams and a final. In addition to that, let's keep going. The only materials you should bring: a writing utensil, your TI calculator, your TI 83 or higher calculator, and I was trying to find. I thought I had some index cards at home, but I can't find any. An index card with whatever information you want to put on it. So again, the size of the index card, I'm not going to nitpick on that. It's just get an index card of reasonable size and put whatever you want on it. Now, the interesting thing is we don't have too many formulas that we're starting off with. So mainly it's how do you do stuff in the calculator. But you're welcome to put whatever you want on this flashcard, whatever you think is reasonable. I am going to put table 2 from the appendix. So just a refresher, table 2 is that one table of critical values when we conclude whether there's a linear relation between 2 data sets. This is going to be included in the test. So don't bother trying to write that on your index card. That's not very practical. This is a table I would just give you. So you might want to just look through the notes, any formula you might see, and if you write small and you don't mind writing it down, some formulas I might recommend. I thought I saw one of them. In fact, we'll go through that later, actually. I'll suggest some formulas you might want to know. Exam 1's going to cover everything we've talked about in class, from the very beginning of the class all the way up to the correlation coefficient, which we finished Monday in class. So that's going to be exam 1. And also exam 1 is a paper test. It's a 100% paper test. We're not doing any part of this online. So there's no online portion. This is all on paper. It means you can provide me scratch work and I can grade your scratch work. So it's not a hit or miss problem every time. So it's a 100% paper test. Besides for that, I think that's all the general information. You'll have the full class time to take the test. I'll probably offer you until 9:30 to take the test until my next class comes in. So that gives you about an hour and a half to take this test. And again, the most important thing, do not show up to this class next Monday. Do not show up to this class. Please show up to the Sims Library, room 208. In fact, I think it'll be, I guess I'll go ahead and change the Google Calendar event to also represent this. So you have another means of remembering. I'll do that later. Does anyone have any questions about generalities of the test before we look at the specifics of the test? Okay, well, for the test, so I went ahead and I thought, let me just go ahead and make a practice test for this. There's a practice test. I'm not going to go through it in class. This is something that you can do on your own. I'm going to spend class time explaining the expectations, things I could ask on this test. And the practice test is pretty much a giant collection of problems that will pretty much encapsulate everything you need to know. Is it completely inclusive? Maybe I missed one or two things when I made this thing, but if you can figure out those 30 problems, there's no doubt that you will probably do very well on this test. Not saying that there's going to be 30 questions on the test, not saying everything's going to be from the practice test is going to be on the exam, but this is as generalized as I can think. And I put some diverse problems on there as well. So there is a practice test that you can look at on your own. You don't have to take the practice test. It's optional. It's if you want to, if you feel confident, or if you just don't care. I don't care either way. It's there for your convenience if you want it. Additionally, there's another aspect of this course that some people might overlook, and it's the study plan. So everyone has a study plan. And what this allows you to do is say, I think one thing that students, I think in this class as well, are not completely fluent at is in chapter 3, under measures of dispersion. I think people struggle to use the empirical rule correctly. I think that's one. So you might want to do exactly what I did. So if you're looking, so let me explain kind of the process. Say you're studying for this test, you get to measures of dispersion, you think, okay, range, that's easy to find, standard deviation, just throw that in the calculator. You know, you don't need to know these awful formulas. So you keep scrolling down. All right, how do I analyze 2 data sets? Okay, well, there it is right there. And everything seems fine so far. And then you get to the empirical rule and think, oh, that's a little fishy. What do all these numbers mean? How do I interpret that again? So this was section 3.2 under the study plan, under all chapters. There's chapter 3, there's section 2. Determine the range, standard deviation, nah, that part's fine. Use the empirical rule. You might want to do that, and that gives you a diverse collection of problems that you can look at if you need some variety, some specific variety. And in particular, if you click on use the empirical rule, if that's the thing you want to work on, you can say quiz me. And it'll give you a quiz that you could try to figure out the empirical rule. I may ask a question on the empirical rule, so that might be
Will
something.
you have the little picture for
The picture.
of the graph, I don't know what you call it.
Okay,
Like that.
yeah, I know what you're talking about. Yeah, I'd rather give that to you myself. Okay, yeah, that's a good point. I'm going to give that graph. Okay, yeah, you do not have to draw.
So I was hoping that you would give it.
You are perfectly right on that. I will definitely. All right, so just to emphasize what you said for anyone else, I will provide this chart on the test as well. You do not need to, you do not have to draw that. That is perfectly fine by me. Okay, so that's going to be on there. The table's going to be on there. Of course, I'm not going to put any of these calculator tutorials on there. I'm leaving that up to you. But so that's some options you have. And another thing that students sometimes miss, under the grade book, it does have your results from your test. Because if you try to go to assignments and you wanted to review stuff on central tendency, you try to click on it and it says, go to results to practice this. Well, there's not really a results section on one of the tabs. Instead, it's gradebook. If you go to gradebook, it's only showing the past 2 weeks. If I show the entire course, then what's that?
You need to tighten up.
I mean, yeah, I'm not a very good student, as you can tell. Need to work on my grouped data. But yeah, so central tendency, if you need to review that, you can go look at any problem. It's going to say, this won't change your score, whatever, I'm just trying to review it. And you can click similar question and work on it again. So these are all various resources you can utilize or not utilize. You have a practice test, which I feel is fairly comprehensive. You have the study plan. The study plan, which can give you specific problems for some particular topic in case you're just struggling with one idea instead of a whole bunch of them. And you have the grade book in case you want to go back and look at anything that we've had a homework on or otherwise. So I guess as far as those resources go, is everyone up to speed with that? So these are all various resources, and you can email me if you need to meet up with me through a Google Meet virtual thing for office hours. Just shoot me an email. That's perfectly fine. Or if you just need to shoot me a regular email, I'm normally pretty comprehensive when I type out solutions. So you can do that as well if you're struggling on something. Just take a picture of your screen, show me some work perhaps that you tried. It'll make it really easy to figure out your problem. But besides for all of those resources, let's talk about what to expect on this test. So that's what what I'm going to do is go through this whole packet and explain what would be expected of you. So there might be a few questions where you have to answer just a definition or two. Pretty much anything in a box could be fair game as some definition I ask. I could ask you, define statistics, define data, define population. I could ask you anything about, or I could ask you something about, here's an example, here's some situation. For example, I could ask you, we want to figure out the average height of students in Southeastern. We sample the Math 241 class. What would be the sample in this situation? And you would say the Math 241 class. I could ask you, what's the population in this example? would be the Southeastern student body. I could ask you, that's a good way to ask you a definition, but how to apply that definition to some specific example. And so, again, I can ask you any one of these definitions, might have maybe a few of them as just quick answer ones. Types of statistics. Definitely want to know what a statistic and a parameter are. I could give you some situation and ask you whether that is a parameter or a statistic. Now, a statistic is a number from a sample, parameter, population. Statistic, sample, parameter, population. So, like example 1, that could be a very reasonable question to ask on the exam. I can ask a few of them, and they're very quick. You either pick one or another. It's nothing to show your work for. I can ask you to define variables, qualitative variables, quantitative variables, or I could just ask you, tell me whether each particular variable is qualitative or quantitative, like example 2 here. I just give you a few of those. You don't show your work, you just answer one or the other. Those are fairly common statistics problems. I can ask you to define discrete and continuous variables, or I could just ask you to determine whether one's discrete or continuous. Discrete is countable, continuous is non-countable. So any of that stuff. So far it's definitions, statistic versus parameter, qualitative versus quantitative, discrete versus continuous. That's the 4 so far. So sampling methods, I can ask you to define any one of these sampling methods. And so, or I can make it multiple choice. Stratified sampling is which one of these? And then it could be, I state all these definitions and you choose the correct one. Or I could give, like in example 1, I could give you a scenario in which they choose or select a sample, and you have to determine whether that sample they selected used, whether that was a cluster sample, convenience sample, just like we did in example 1 here. So convenience sample, cluster sample, systematic, blah, blah, blah. So that's pretty much chapter 1 in a nutshell. That's pretty much everything we talked about in chapter 1. So any one of those things could be fair game. So definitions, statistic versus parameter, qualitative versus quantitative, discrete or continuous, the types of sampling, either as definitions or determine the type of sampling given a particular prompt, like example 1 here. We move on to chapter 2, where we deal with some numbers. I could very easily ask you to make a frequency distribution table. I just list out a bunch of values. You make a frequency distribution table, which frequency just means how many. I can additionally ask you to make a relative frequency table, or just add a column and put the relative frequencies on there. Remember, the relative frequency, it's whatever frequency you found divided by the sum of all of them, which is what proportion of your data is that particular frequency. I could easily ask you to do that, like in example 2. I could ask you to construct a quick bar graph given your results from the frequency or relative frequency distribution. Like we did in example 3. Or I could say organize your bar graph in descending order, which is a Pareto chart, which basically just says organize your bar graph to where the largest one's on the left and the smallest one's on the right, and in between the heights of the bars go in descending order. Just like example 4 here, where of course the heights decrease. You might have to extrapolate, or is it interpolate? Whatever the case is, you might have to work backwards and use a frequency or a relative frequency bar graph to determine the number of people that may belong to, say, in this example, we did how many students are NHS majors, nursing health sciences. You see that that's about 25%, because this is relative frequency. And then 25% of the total 14,461 would tell you how many. So I could easily ask you to interpret a bar graph. Instead of build a bar graph, you interpret one. Same thing with a side-by-side. I can ask you the same exact questions about a side-by-side one. So that's section 2.1 on qualitative data. Quantitative data, it might be worth knowing when we use a bar graph over a histogram, because they're pretty much, a histogram is pretty much a bar graph. The only difference is we use a histogram whenever the x-axis is quantitative. Might be worth knowing that. So notice I wrote that here for a histogram. So might ask you to do this about quantitative data. So basically, instead of the categories of the variables being just random categories like Instagram, Facebook, Twitter, where none of these categories have any relation among one another, I can ask you something. So number of siblings. Remember, this is quantitative because you can add or subtract numbers and it still has a meaningful interpretation and relation to the original number. I can still ask you the frequency, relative frequency of all of those. I can ask you to make a histogram, not a bar graph, but a histogram from all of this information. I can ask you to determine whether this bar graph is skewed or not. I think we'll talk about skewed here in a bit. I can ask you to define a class. Ask you to find I could give you a data set and ask you to determine the classes yourself. So remember, classes are the intervals that you need to create because it wouldn't be practical to count all the occurrences of these numbers that are, say, in example 2. You have to create intervals so you can organize your information a lot more easily. You might have to create your own classes, or I might give them to you, and then you construct a frequency and relative frequency distribution. You would need to tell me the lower class limit or the class width. I can define it, or I can either define it or ask you to find it for a particular problem. Or if I ask you to create your own intervals over here, then I would ask you, what is the class width of the intervals you just created? The class width is the difference between consecutive lower class limits. So I can ask you any of that information. So again, what I said about creating your own intervals would be like example 3, when I asked you all to Google how far away you were from campus or how far away your house is from the campus, and we constructed everything ourselves. You might have to recreate that on the test. And possibly even create a table or a histogram from that. If I asked you to do that, I would probably give you a small template like I have here. I could ask you, I can ask you about the skew of a distribution. If I ask you this, it would be probably pretty straightforward. Just keep in mind though, because a lot of students get this confused. So for the one I'm highlighting right now, this would be skewed to the right because the tail is on the right. A lot of people say it's skewed to the left because it seems to be more concentrated on the left, but the skew is in the direction of the tail. In other words, we have to stretch out the graph even further because there's some outlier that we have to account for. And I guess speaking of resistant variables, I could ask a possibly tricky or not tricky question about whether a certain measure is resistant or not. I can ask you to define a resistant variable. So I don't think I mentioned that already, but I've periodically had questions in the notes that have asked, is this variable resistant? Is the standard deviation resistant? Is the range resistant? Is the median resistant? I can ask 1 or 2 of those on the test, and that would be very reasonable to ask. That means you probably need to refresh yourself with what it means to be resistant and which variables are resistant and which variables are not resistant. That's another very justifiable question to ask. Stem and leaf plots, not doing that. So no stem and leaf plots. I don't like those. So that's chapter 2. We move on to measures of central tendency. So again, I can ask you to define the mean. You can either give the formula or just tell me what it is. It's the average of all the data values. That would be a perfectly sufficient definition for me. I'm not going to ask you to recite these formulas by any means, but it may be worth knowing the notations. So the Greek letter represents the population mean, and the X with the bar on top is the sample mean. It may be worth remembering the notations because we use the notations in more than just the situation. They come up in other situations, so you need to know those notations, and that those will specifically tell us whether we're dealing with the population or the sample mean. Normally, the population variables are Greek letters. You'll notice that for the standard deviation as well. So, in other words, parameter measures or parameter values are Greek letters generally. And then statistic values are generally just casual. like x with a bar or just a lowercase s. So I could easily ask you to find the mean of a data set. I can ask you to find the median. I can ask you to find the mode. All of your standard measures of central tendency. I might ask you to find any one of these without the calculator. So hopefully you all intuitively know how to find the mean of a data set. So you would just write down your steps on your paper, just you adding all the values together and dividing by the number of the values. I could easily ask you to do that by hand. I can ask you to find the median. I can ask you to define the median. Or I can ask some problem that implicitly wants you to find the median, like we did in example 2. So if I tell you that 1, 4, 6, blank, 10, 15 is the data set, and that the median is, let's see, I guess 8. If I tell you that the median is 8, then you have to tell me the middle value. So I can implicitly ask for not the median, but a value that results from the median being 8. So if that was x, this would be 6 plus x divided by 2 is equal to 8. So x would be, was that 10? 8 times 2 is 16 minus 6, x is 10. So something like that. And I can ask you to find the mode, the value or values that occur the most frequently. I could just give you a list of data, a fairly small list of data, and ask you to organize it and determine the mean, median, and mode without a calculator, which means by putting it in ascending order. I mean, you can figure out the mean regardless of its order or not. The median, though, you could just underline the value. It's not a big deal. There's not much to show in the mode. There's even less to show. So I can ask you to do it all by hand. I could ask you, why would we pick the mean over the median? Remember, we would, and normally the mode, well, actually, it just says it all down here. Or rather, there's a precursor to it down here. The mean is skewed by outliers very easily, and the median is not. So we tend to use the median whenever we have skewed data. If we don't, the mean is a good measure of central tendency. And we use the mode whenever there's qualitative data. So I can ask you anything about that. Again, here's the idea on resistant measures that I mentioned before. I've asked periodically throughout this class whether certain values are resistant or not. So I could easily ask if so-and-so value is resistant or not resistant. So the median is not resistant. The mean is resistant. The standard deviation is resistant. The quartiles are not resistant. So these are stuff you would see in the notes. So again, I can ask you to interpret this and determine the skew from this as well. Or I could just give you some graph and ask you to tell me its shape, like I mentioned before. And from that shape, would you rather use the mean or the median? And of course, there's problems where you'll be given a relatively few number of data values, and you figure out the mean and the median and the mode from that, just using the calculator. So pretty straightforward stuff. Or it can ask you to figure out the mean, median, and mode from 2 data sets, which means you would just do both of them in the calculator, which we did talk about a little bit later. So we move on to the measures of dispersion. Basically, a lot of the stuff repeats the same. I might ask you to define the range, find the range by hand, or use the calculator. Standard deviation, I might ask you to define it, determine it by hand, or use a calculator. Oops. There we go. Now, if I asked you to do the standard deviation by hand, it's not a very nice formula, so it would be a very small number of data values if I asked this, maybe like 3 or 4. So remember the formula. So I think earlier I said you don't need to know this formula. I think you do if you have to do this by hand. So you might want to keep a hold of those formulas, or remember how we did the problem in the notes, for example, 2. If I asked you to do the standard deviation by hand. And generally I would ask the sample one. We don't tend to use the population one too much in this class. But again, you might want to know the symbols. Sigma is the population standard deviation. Lowercase s is the sample standard deviation, mainly because that notation does come up in other situations as well, other formulas, which inherently means you need to know what these symbols refer to. Variance and population variance and sample variance. I can ask, what is that related to? The variance is the square of the standard deviation. That'd be a quick definition. So really, I could ask you any question regarding finding the standard deviation in the range or the variance by defining them, finding it by hand, or using the calculator. And if I ask you to do 2 data sets simultaneously, I explain how to do that in the calculator. And there's also the empirical rule, which I think a lot of you need to work on. It generally trips up people in 105. I wouldn't be surprised if it did the same here. This exact picture you see here, like I said, that's going to be on the test. This picture right here with all the wording as well. So it'll say 99.7 here, 95. It's going to say all that. And this tells you the proportion of people that lie within a certain standard deviation of the mean. So I can ask you 1 or 2 questions regarding that. I think that's definitely a very fair problem to ask. So you might want to practice empirical rule problems. So the common ones, about 68% of resting heart rates will be in between which values? And you see 68% up here, which means that we are 1 standard deviation below and above. So you need to figure out 1 standard deviation below the mean and 1 above the mean to figure out the interval, because it says between which values. This is fairly typical for these types of problems. Or if I gave you the values themselves, you would have to tell me the percentage of values that lie in between them, or the percentage of values that lie above a certain value or below a certain value, using this empirical rule. So in a nutshell, that section is range, define it, find it by hand, or use a calculator, standard deviation, same thing, and empirical rule. I think that's pretty much what it comes down to for that section. Grouped data. Remember, grouped data, we use this class midpoint, which is the middle value of each class. So if we have these categories that are represented by intervals, then the midpoint would be the number that best represents that interval, which is the mean. So the midpoints in example 1, so 0 and 1,000, their average would be 500. And then 1,000 to 2,000, their average would be 1,500. And so each one of these would be the representative for the intervals. And this helps us find stuff like the mean. These are part of this idea of weighted means, or even weighted standard deviations. Blah, blah, blah. So we talked about example 1. I'll probably be asking a problem from this section. I can ask you to define a class midpoint, or tell me to find the class midpoints. And use that to determine the mean and the standard deviation, which I explain exactly how to do that in the calculator exactly below. So I can ask any one of the questions from this section on weighted means and standard deviations. And so that's pretty much the only variety there. It's the same idea. I can either ask you to define it, or more likely determine the class midpoints and tell me what the mean and the standard deviation are. There's not too much variety in this section. Or I can ask you a weighted mean problem, which I believe there's a weighted mean problem in the practice test as well. Move on to the position and 5-number summary. These were the formulas I was thinking about. Namely, probably going to stick to the sample z-score. But these formulas, which they really mean the same, and this is what I was referring to about you need to know what these symbols mean. Because out of context, it may not be clear what any of these refer to. So that's why I was emphasizing the importance of knowing these symbols. That's the population standard deviation. Over here, that's the sample standard deviation. Again, you can write that down on your flashcard, or you don't have to, but that's why these symbols come into play. When you're using formulas that are based off of these formulas, then you need to know what these symbols represent, or else you're not going to plug in correctly. So these are important formulas. So the z-score is an important formula that you should probably have jotted down somewhere. So I could easily ask you to find the z-score of a data value when I give you the standard deviation and the mean. Like we did in example 1. I can ask you a percentile problem, or even just define a percentile. I can ask you a quartile problem, or define what percentage of the data any one of the given quartiles is above. Or in other words, what is the percentile of any given quartile? The first quartile is the 25th percentile because it's above 25% of the data. Second quartile is 50%. Third quartile is 75% above. So stuff like that. Again, another resistant thing. Here we said that the quartiles are resistant. I ask you to find the interquartile range. That's another formula. You might want to jot that down. Or the fences. You might want to jot those down. Those are just more formulas. So I can ask you to determine the 5-number summary, which is given directly in your calculator, even in order once you type in all the data values. So if anything, you should not be able to mess up stating the 5-number summary. I can give you just a collection of raw data and ask you to tell me everything about it in terms of the 5-number summary, interpret the quartiles, determine the range, tell me the fences, and tell me any outliers, if any. There was a rule as well where we mentioned, he asked, is Q3 minus Q2 greater than Q2 minus Q1, which helped us determine skewness whenever we're dealing with the mean. That could be something that's asked. If I did put that on the test, I'd make it pretty obvious one way or another. Again, I could ask you z-score problems or ask you to interpret the z-score. A positive z-score means your data value is above the mean. A negative z-score means your data value is below the mean. And the magnitude of the z-score tells you the number of standard deviations from the mean. I can ask you to draw a box plot of a 5-number summary. So remember, a box plot, a single box plot looks like this, roughly like that. We drew one in the notes, and you can look at that one as reference, but I could easily ask one of those. Or I can ask about 2 of them, and you just have to interpret from 2 of them. The last section, I could ask you to define a response or explanatory variable. I can ask you to determine the response or explanatory variable for 2 data sets and provide for me the scatter plot. You'd have to just draw the scatter diagram, whatever it is. If so, I would give you a graph for that, like you see here. I can ask you to determine if 2 data values suggest to be linearly related by the results of a scatter diagram, or equivalently by their correlation coefficient. Remember, just figuring out those, it's not conclusive quite yet, but you can state whether that suggests a strong or a weak linear relation. I can equivalently ask you if this correlation coefficient shows that we conclusively have positive or negative association via a linear relation. And that's when we use the table at the end of the notes. That's when we use that table 2 from the appendix. That's when we use this table. So again, I might just give you a scatter diagram and you just tell me, does that look like a positive association, negative association, or neither? Something like that. Again, definitely make sure that your calculator is set to diagnostic on. You only have to do this once. If you don't do this, if you don't do this, then your correlation coefficient's not going to show up in the calculator, which is going to be a bummer. And if that happens during the test, you can just call me over and I'll fix it for you. It's a very quick thing. But again, I can ask you to determine the linear correlation coefficient and then interpret whether this suggests a strong linear relation or a weak one, and then determine it conclusively by using the steps that I talked about in this little excerpt here. Ask you to mix and match. And again, this explains taking raw data and, well, this brings everything together, taking raw data, determining the response and explanatory variables, drawing a scatter diagram, determining the linear correlation coefficient, and then determining conclusively if a linear relationship exists between the two. And I can very easily shove this into the test as well. So I'll just put that right there. And that, in a nutshell, is the entirety of things I could ask on this first exam. I'm not going to ask everything, but if anything, I will try to at least have one thing from each section. That's pretty definitive. To the extent of these inclusionary topics from each section, that's going to be something you find out when you take the test. But that should encapsulate all of it. Does anyone have any questions about any of this whatsoever? If you have any questions about the homework or the quiz, I'll stick around. I have nothing else to talk about for today. Yes.
The exam, the practice exam that you put on there, the 30 questions, if I was to retake it multiple times, would it like shift? Would the questions like shift?
I have it set to where they will shift.
Okay.
I can also put it back in order. Does that matter to anybody? Does anyone want it in order? You want them in order?
Yeah, because like when I go, like if I write all my work and I get wrong, I go back and see exactly what I did.
That's fine. They're almost perfectly in order. So I can switch them back to the in order thing. That's no problem. Let's see, I could do that right fast. Edit. Where's that? Scramble question order. Nah. So you could probably follow along with this and with your notes, so concurrently. So as you see problems. So I'm not going to go through it, but I'm just going to pull it up as a preview and just kind of show you what to expect. So the first two questions are like definitions. Those kind of go around from, that can be chosen from any one of the 4 chapters. But then after that, so definitions, and then it's slowly going to go in order. So now it talks about perimeter and statistics, qualitative, quantitative, discrete, continuous. So that goes in order. And if you keep restarting the test and going back in, I tried to put a lot of variety. So you should see a good number of problems kind of, you'll see a good number of alternates. I tried to make it to where you could see many examples if you so please. So, all right, I fixed that. Is there anything else? If not, again, that's all I have. I'll leave it at that for today. If you have any questions, email me. please go to the library for the next class period. Don't come here. We don't take the test here. We take it in the library. I'll make sure to give a few reminders about this.
You have a good weekend.
All right, take care.